morning and welcome to a new week and understanding geography further. Today, let me say we might, or rather we are going into a bit of your syllabus. I I would still agree that actually I have not shown you the syllabus as such, but as you must have seen that studying geography does not require a syllabus. You can actually keep on studying geography without a syllabus, and you will end up doing a lot of the things in the syllabus as such. But anyway, just as it has been happening for the last few weeks, we are not going to have our lecture tomorrow. We will have it on Saturday. So we continue with the trend of having 2 lectures in a week. And Saturday, I should be in a position, if we finish with the PPT that I'm going to refer to today, if we finish it appreciably, then I will go back to the syllabus. I will make you understand the syllabus, and then we'll proceed further with the other aspects of the syllabus as such. Syllabus as such. Just like we do every time, a bit of the college bulletin as such. You must be aware that a few days ago, we have posted the notice regarding the change of subject and the change of medium. I will not go into the details of explaining that again, basically because of the fact that I have already spoken about it in detail. And secondly, the required details are mentioned in the notice, which spells in 2 languages, English and Marathi, both of them. The last date, if you see, for the notice on the website has now been extended by another 2 days. So if you are still thinking of changing and opting out of a subject, opting into a subject, given the circumstances in which you would be required to file your requirements, your changes, we can always look into that aspect also. That was one thing. Secondly, as far as the medium of instruction, the platform of instruction, I would rather say, is the colleges has, say, more or less finalized G suits. But till the time we get the official things and you get your credentials as such, I would still be continuing on StreamYard. I find StreamYard to be very comfortable as such. And because of that, I normally tend to will continue. Of course, time and again, we would be moving to G suits where we would be taking up the other aspects also. A lot of girls have joined in, and boys, of course, also. Swapnil, Rishikesh, Avikshit, Danish, Tamboli, Mayuri, Arya Durga, Sandeep, Saloni. Very good morning to all of you all. And as we grow in number, okay, we have now 37 and I'm expecting a few more. I would, I do recollect a few things that we did last time. We were still into the equinox. Bhavika, good morning. Shambhavi, good morning. A question that I remember of is in a lecture before the last one, so probably last Thursday, I would say, a student had asked Anushka, good morning, what are corals and what is a coral ecosystem is a question that some student had posed. My answer to that would be that this is something that needs to be done in zoology more than in geography, but I have always believed geography to be a subject which is a jack of all trades. Sandeep is sharing something. What is he sharing? This year's Physics Nobel Prize. Sandeep, your spellings, get your spellings right. Me parva sangitle, please get yourselves dictionaries and make it a habit that you spell your spellings correctly. Anyway, This year's Physics Nobel Prize goes to Milky Way galaxy. So what is equal in physics and geography? I am going to come to what I am, rather a place wherein, or rather a session in today's lecture wherein I would be uh, speaking about geography as an extensive aspect. But let us start with what we are supposed to be doing. And okay, this is what I am supposed to be sharing with you all. And yeah, so this is one of the first PPTs that normally I discuss with students who want to get known to geography as such. Okay, it could be school students, it could be college students. When I go for public lectures, this is something that I want people to understand that what geography is all about. Yes, he was speaking about Milky Way and geography, and that the physics Nobel Prize in physics is being awarded to someone doing research on the Milky Way. But let me tell you that geography is known as the mother of all sciences. I think this is the third or the fourth time I'm repeating this. And geography is a skill that you normally require as far as understanding life is concerned. And that is why you'll see that the title of this particular session is Geography of or Geography for Life. Now, what do you see in that? Okay, of course, I have added a few GIFs and photographs, and I've put all of these together. And in this, you would see that you see a human face, and of course, you see the map of Africa just in front of that. I think this is not I wanted to um, portray as far as sorry. I've just changed the settings a bit. Probably I wanted you all to see the larger of the slide rather than larger of me speaking. Let us see how it turns up. I'm playing the YouTube channel next to me. Well, let us see how it turns up. I've just changed the setting a bit. But as I said, that in this slide you would see a human face, and you would see the map of Africa being portrayed at the forefront of this particular face. Far behind you see the Earth, which is a blue planet as it is called. The reason it being blue is the gases and the particles in the atmosphere rather than anything else. And of course, the GIF that I have inserted as far as this particular first slide, introductory slide, is concerned. Let me come to this aspect, that it was Sir Patrick Gittes who, for the first time, referred to this. That was what I was initially referring to. That he called geography the synthesis and the mother of all sciences. Okay, you'll see that geography started in itself as an informative science. Now, I call it as a science basically because you are learning what are the processes, things that are happening. For a significant period of time, I would say that we tended to look at geography as an informative science, but geography is sometimes considered to be as the mother of all science. due to its links and influences on a range of other scientific fields. Say, for example, biology. Okay, like I was referring to the fact that uh, somebody was asking about coral reefs, and I needed to speak about that. But then that is biogeography, wherein I am referring to a life form in a particular ecosystem at a particular place. So coral reefs, or what is also called as the Great Barrier Reef as such, then mathematics, all those calculations of the length of the days and nights and the distance between the earth and the sun and the other aspects as such, all of these include, so to say, the mathematics in it. And then, uh, yeah, now I see that you are seeing the right thing. And then anthropology, of course, the face that we spoke about behind that map, okay, is all how human beings are actually placing themselves on Mother Earth, and how they are changing the face of the Earth recently. The geology, the economic aspect, to the natural aspect, in the sense the economic aspect being the minerals, etc., and the natural aspect being the volcanoes and the earthquakes, the astronomy, the chemistry. I could just go further and further saying the physics of it, and so on and so forth. So geography is also called as the mother of science. I'll be coming back to these statements again and again when I do refer to the other aspects in our syllabus also. Um, then, if I am to define geography in the shortest one, somebody says that, so you have to define geography in, let us say, not more than 10 words. How would you define it? After a lot of thinking, I would come to this particular definition, wherein I would call as geography as the study of the earth in space and time. What does this actually space and time mean? Again, I would remind you all that in my first or the second lecture, I've already spoken about the concept of space and the concept of time. But here again, we need to address to that space is a spatial location. It could be the location of the sun in the Milky Way, or it could be the location of the earth in the solar system. It could be the location of land and water on the earth. It could be the respective continents on the respective, let us say, the hemispheres as such. So all this defines space all the way to in a continent. Let us say we have a country like India, and in India we have a state like Maharashtra, and in a state like Maharashtra we have a district like Pune, and then the Pune city, and you individually are placed in your own homes. Now, had we been doing this lecture in a class, all of us would have been located in SP College. But now, since we are conducting this lecture virtually, all of us are placed at our respective, what should I say, residences, and we are addressing. So, from a very large scope to the minus, this is called as actually the scale. And if you have followed what I have been speaking about, right from the Milky Way, I could have started from the universe and the galaxies and so on and so forth. But right from the Milky Way all to the place where you are sitting now, okay, I have scaled you down from a very large scale to an individual scale, and that is what I mean here as man in this scale. Okay, you will see that if I start from the Milky Way and come down to the sun, and then the solar system, and then the earth, and then the respective hemispheres, land and water, and continents and countries and states and districts and cities and individual location, you can just imagine the rate at which scale moves. If you remember, I've said this earlier also, that if I am to choose 50 words of geography as a subject, scale, space, time, geography, of course, in itself, maps, all of these are going to be important. That's the importance of the word scale in this whole scenario. When we speak about space, anything that occupies space. Now, you are sitting in your homes, you are occupying space. Your home is occupying space in the city is occupying space in the district, and that is how you keep on growing in scale. What exactly do we mean by a scale? It is basically the representative fraction Okay, now when, say for example, when we are looking into a map, okay, you look for a map of the world, and you will see that you have the map of the world in your hand, but obviously you know that that is not the actual world. But then how do you represent it? You use a scale. Say for example, 1 centimeter on that particular map could be equal to 1,000 kilometers or 10,000 kilometers, given the scale of the map. The larger the map, and so on and so forth. You'll see that you have maps of different scale also. At some point of time, we'll come to that also. I'm going to go into a bit of spatial scale and location in the further slides. But then there is another aspect to this scale, and that is time. Okay, so a geographical term I would be using for space is a spatial location, and for time, the word I would be using is temporal. So you have a temporal scale also. And again, I remind you of one of the statements I have made in one of the earlier lectures, that the fact that time can be split into microseconds, and of course, time can travel into billions of years also. We did the fact that the age of the Earth is 4.6 billion years, and from that to today, if we reach that particular point, I'm going to show you the geological time scale. Of course, not in detail. We are just going to, because the title of this topic is Basics of Geography. So while we study geography as a study of the Earth in space and time, the spatial locations and the temporal locations, we need to understand it in the concept of scale. Geography, the word scale is very important. And of course, where is man placed as far as this scale is concerned, as far as individual location is concerned, as far as his time location, how long has man been on this particular planet, that would come in the temporal scale. And where is man located, where are you located, where is I located, would come as an locational scale or a spatial scale. So that is how we differ it. A misnomer, or I would say a mispronunciation, that normally a lot of students go into is that the word spatial, S-P-A-T-I-A-L, I have seen good students pronouncing it as spatial. No, it's not spatial, it's spatial. The T is a bit silent here. It's not, you don't stress the T to say make your tongue rap against the top of your palate. Okay, so of your mouth as such. So it's just the gentle T. So spatial is the location. And I would in fact go further to clarify a few issues that we normally experience in geography. And uh, this goes to do with a lot of diagrams that we tend to see in our geography textbooks and so on and so forth, wherein many times you'll see that the sun is shown small and the earth is shown big, and at times you'll see that the sun and the earth are shown to be of the same size, and so on and so forth. And I've seen many students in geography and otherwise also getting misconceptualized about these proportionate sizes, and that is why scale is very important. So putting all of this in the right proportion, I would say this diagram should in fact put all the questions and the discussions to halt. I've purposely put up this particular photograph, I would say I picked up from Google. This shows the comparative size of the sun and of course the planets. Now, if you can see the largest of the planets, Jupiter, it is said that it is still solidifying. A lot of it is a very amorphous. A lot of the surface of Jupiter is amorphous. But given the size that we can visualize of Jupiter, you can just compare the size and see that it is significantly small. And then you come down to the other planets as such, in the sense a smaller one is Saturn, and then you have the two planets of Neptune and Uranus, and then you have the smaller planets. Okay, you'll see that Earth is the larger of the smaller planets, but you can see that in this whole scenario, it is just a dot. And in that case, it would be very absurd to place the sun and the earth to be of equal size, or in fact at times the earth to be larger and the sun to be smaller. But let me tell you that as far as geography is concerned, as far as learning geography is concerned, I've already told you that this is the study of the earth. So what happens is when a subject is studying earth, earth becomes the center of attraction. And obviously something that you have to emphasize on obviously has to be zoomed into. And when you zoom into, you must have seen this in these movies wherein you are focusing on the hero or the heroine of that particular scene. Things towards the black say background, they go blurred, or they play all those camera tricks. That's basically you need to focus on that. So when geographers drew diagrams in your textbooks and showing the earth equal to the size of the sun, or at times larger than the size of the sun, it so happens that what they want to emphasize is that you should be concentrating on the earth aspect of the whole phenomena rather than the sun. Of course, the sun is very important, and without the sun, this is not going to happen. But when we understand the earth, we have to understand the earth first. So you have to make the earth prominent. And because you make the earth prominent, obviously you have to just put down the sizes of the other issues on that. So that is why you will see that normally in geography textbooks and otherwise also, the earth is comparatively shown as large as the earth, at times larger than the earth. The earth is shown larger than the sun, and at times equal to the size of the sun also. There is another thing that might have confused you, I don't know, but I need to clarify those issues also. Now just imagine that when if you have seen small kids being asked to draw the sun, you'll see that they'll draw a small round, and then they'll draw those rays. Now, if you have ever observed, okay, there comes the science in geography. If you have ever observed how they draw the rays of the sun, you'll see that the rays tend to radiate away from the sun. They go in all the directions. But when you must have come to standard 6th, 7th, and 8th, you'll see that when your teachers taught about the the whole issue about parallel rays of the sun striking certain part of the earth and so on and so forth, then they say that the rays of the sun come parallel. Now, isn't this weird that at some point of time, say earlier in our life, we are drawing the sun's rays radiating away from each other. On the other hand, you tend to draw the sun's rays coming parallel. So the moment you start getting a bit scientific, they get parallel, and when you are free to nature, it is not parallel. How can that be? The answer to that lies in this particular diagram. The sun is so huge that though it radiates away its radiation, and yes, the word is radiation, it radiates in different directions. And the diagram of the sun and its radiation you drew in your first and second standard is absolutely right. So does that mean that the diagram you were asked to draw in your examinations in 7th, 8th, and 9th was wrong? That also is not wrong. Basically, the concept of scale comes in. Now, if I use this particular size of the sun, and I would make the sun radiate its energy, and this radiation of energy is going to reach the size of the earth that you are seeing in this particular photograph. It is but obvious that by the time you zoom in to the rays, they would appear to be parallel to each other. If you go very precise, yes, there would be microns of difference as far as two parallel rays are concerned, but for the human eye, it would seem to be more or less parallel to each other. So remember, it is more or less parallel. And given the scale at which human beings see them, I would confidently say that yes, it is parallel. So the scale is very, very important. And then the reason why both the picture that you drew of the sun in first standard and the diagram that you do for your exams in the 8th or the 9th standard are both of them are same, basically because you were doing it at different scales. Okay, that was this size of the sun was made very small by you when you were very small, aware of when you yourself were small as well, and thus the radiating rays of the sun were fine then also. And by the time you started studying the earth with reference to the sun, and you brought up the size of the sun to a size wherein you could scale it, you could understand it as a part of your studies, those radiating rays reaching the surface of the earth were again seemingly parallel to each other. They would not be, as I said, mathematically, precisely, they would not be parallel. But the human eye, the human scale, yes, they would definitely be parallel. I was to go to a slide which would be a succession of this particular slide. But as far as, let me say, a topic that I have been asking you all to repeatedly refer to, go to Google, search for it. And I did that purposely, basically, because of the fact that that is something which is being discussed very regularly around us. And if any one of you have guessed this, yes, it is climate change. By the way, because I'm sharing my screen, I am not able to look into what comments you are posting. I would obviously go back to this when I finish with my lecture and see whether you are commenting and you had any questions. But I would request you all that you could note down these questions and post them in our group as well. I will try to answer it there, or when we meet for the lecture day after tomorrow. So coming back to the next interesting, yes, climate change, and I have asked you all to go into the details of the Milankovitch cycles. Here I found a few GIF files as far as the Milankovitch cycles are concerned. What exactly does this mean? Now let's start with this particular the white diagram here. These are the three cycles. The cycle of eccentricity is the extreme left, the cycle of obliquity is the center one, and the cycle of precision is the right one. We are trying to, we would be trying to understand what all this is. The reason that it is called as a cycle is all of these, they are working in tandem to each other. But let me tell you that each of them has their own years of cycle. In the sense, you'll see that when I'm speaking about the eccentricity, you'll see that the orbital or the orbital eccentricity, as some people would call it, you can see it here in the GIFs that the central position here, that the Earth is moving in a circular position. Absolute circle, of course, presently it is not absolute circle. It is an elliptical orbit, and that elliptical orbit also is not a perfect geometrical figure around the sun. You will see that the sun is nearer to this orbit towards the southern part of the diagram, and it is away from the orbit towards the northern part of the diagram as such. Presently, you'll see that the orbit of the sun is moving like this, and you'll see that this orbital eccentricity has a cycle of around, say, 1 million, say 500,000 to 1 million years. So what does this cycle and 500,000 to 1 million mean? Sorry, not 1 million. Sorry, it's 1 lakh years to 4 lakh years, to be more precise. So the changes in the orbit at which the Earth tends to go around the sun, it occurs in a span of 1 million to 1 lakh to 4 lakh years. Okay, I'm purposely mixing you because I've made it very clear the difference between a lakh and a million and a crore. So while it would start at 1 lakh, okay, it would go to 2 lakh years, 3 lakh years, and possibly after 4 lakh years, the orbit would be the same it was that was 1 lakh, say the start of the 1 lakh years. So that is how we understand this eccentricity of the orbit as such. So that is just one aspect, and in fact you'll see to the extreme left, you will see that how the orbit of the Earth is switching from a near round to a near elliptical, and so on and so forth. It is compressing into a circle here, and of course it is going back to its eccentricity. Now this is what you are say viewing in a 2-dimension. Let me tell you that it would go up and down also. So we have to change this into a 3-dimensional aspect, and in that case all of this would again be significantly different also. So that is as far as the eccentricity, the first aspect of the Milankovitch cycle is concerned. Then what should I take? Okay, I'll take the tilt in the axis. The tilt in the axis, I'm going to have a few questions for you all after we have understood this. That the tilt in the axis, we all know. The other day somebody did mention that it is between 21.5 degrees to 24.5 degrees tilt to the northern pole or to the absolute north as such. And this tilt has its cycle of 41,000 years. So what does that mean? You'll see that if for a particular year the Earth's axis was 21.5 degrees, now for a significant number of a few million years in the past history, it has not been that. Somewhere way back a few 100 million years ago, let us say it is say 40,000 years ago, it is 21.5. So you'll see that from 21.5 to 22.24.5 and 23 and then 24 and 24.5, this movement in the tilt of the axis is taking a time of 41,000 years. So just like I said, that you start at 1 lakh years, you go and you come back. A similar thing happens with the tilt. That's right from year one, where it could be 21.5 degrees, it could go to 25 and come back in 41,000 years. Now, what are these effects going to be? We are going to understand, and in fact, that is what we need to understand as far as geography is concerned. Just knowing facts about geography is not important. The processes responsible for these facts are also very important. By the way, if you are able to see the YouTube link to this, okay, you could use that link, and you could go to YouTube and just check a small documentary or a film on Milankovitch cycle. So that is the axial tilt. So you'll see that the tilt in the axis going 22, 24 back to 22. I'm just rounding it up. That is a cycle of 41,000 years. Then the more confusing one, and that is why I have kept it the last. The more confusing one is the precision. Now, what is this precision and what is this cycle of 26,000 years? Now, let me tell you that when I'm saying the tilt in the axis, it is a two-dimensional shift. Okay, it is a two-dimensional shift from here, back, forth, back, forth, back, forth. Now, if while this is happening, if the axis starts moving like this, okay, like this is called as precision. Now, have you seen this movement? Yes, when you were young. I don't know how many of you all have played a top, okay, a tabletop. Okay, you'll see that you see when I was small, I used to do that. You just tie a string across that top and then you sling it, and the top starts rotating along its axis with a tremendous speed. But if you have if you can recollect, when the energy of that particular top starts coming down, instead of spinning very fast across its axis, the top starts to topple. Okay, you'll see that it starts doing this. Okay, remember there is a difference between tilt and precision. Okay, now if you are looking from the top, okay, you are somewhere top of the North Pole, and you see this is how the tilt would look to you from say 22 to 24, 22 to 24, and precision would be something like this. Okay, so and it's in combination. As I said, the tilt would be changing and the precision would also be changing. So this cycle of precision is 26,000 years. What are the effects? I want you all to search on Google. What is the effect of this on the orbital of the orbital eccentricity on life of Earth, or let us say basically the Earth? What is the effect of the axial tilt on the Earth, and what is the effect of the axial precision on the Earth? I think I asked you all to look into if when I was referring to last Thursday, I suppose when you were speaking about the lecture on MOOCs, I asked you all to look into an app by searching by the abbreviation BYOE, Build Your Own Earth. You type Build Your Own Earth or you type BYOE in Google, you will immediately be directed to that. An app, I would say, made by the University of Manchester, which is a virtual tour to all these things being done there. Okay, so you change the axis. Of course, that is that gets very virtual and abstract, that you can just bring down the axis. But let us be more factual. Go to Google, go to Wikipedia, and search for what happens to the Earth when the say the orbit, the shape of the orbit changes, the axis, the tilt in the axis changes, and of course the precision movement of the axis with reference to the whole rotational activity of the Earth as such. So That is something that I wanted you all to understand about the Milankovitch cycle. Every now and then, you would be required to link something that we are doing, some phenomena happening somewhere, at a very large scale, of course, to something related to this. And I would want you all to think about it at that particular point of time, that which of these three are responsible for. These are the causes, let me tell you. These are the causes. Now, again, I would like to give you an example as to how we tend to mix ourselves and confuse ourselves between causes and effects. Now, say for example, an example when we say that let us say that the poles, the ice towards the poles of the Earth is melting. Now, the moment you say melting of the ice on the poles, you say climate change. Okay, yes, it is climate change, but I would add a word in that. It is an effect of climate change. It does not cause climate change. It will have a repercussion effect. It will have a trailing effect. It would have a further effect also, but it doesn't start by itself. The reason to the melting is rise in temperature. The rise in temperature would be related to something amongst these at a particular location. So these are the basic causes. And the effects is something like a loss of habitat, say rainfall changing, the amount of rain changing. In fact, you'll see that these days we have been observing that rain does come, and uh, that the average of the rainfall during the monsoon at different places has not changed, but still you'll see that the frequency of floods has increased. Of course, there are two aspects to this rise in frequency. These frequencies on the human side first have increased basically because you have gone into a lot of concretization, and water can hardly seep down into the surface, so it flows on the surface faster, accumulating in a channel faster, and thus you're going to have flooding. That's one thing. And the second aspect is that this rain is falling with a higher intensity. Okay, because the number of rainy days has gone down, but your average has not. This is the mathematics of it now, of geography, how geography uses other subjects. Okay, and while other subjects would have their packed laboratories like physics and chemistry, for geography, the whole earth, okay, the whole nature is a laboratory, and you'll see that these things tend to happen. Anyway, coming back to the fact that we say that the rain average has not dropped, but the rainy days have dropped. So that would mean that the same amount of water falling in a lesser amount of time. So obviously the intensity of rain is going to, precipitation is going to be higher. So the speed of collection of this water is also going to be faster. So it's going to accumulate. It's going to take further more time to drain. So while the water accumulates here, it is going to cause flooding and water logging in different parts. And as far as urban areas is concerned, you'll see that these are being seen in urban areas more basically because what have we done? When we construct housing societies, when we construct roads, when we construct railways, when we construct buildings, when we construct parks, we are in a hurry to level off those surfaces because that is an economical way of using land. Okay, land is a very important commodity in economic geography. But coming back to this, so we tend to flatten out the land so that we can use this space maximum. But in this case, what happens that we lose on to the natural slope that the surface has. And this natural slope would have given a natural flow to the flowing water. Unfortunately, this doesn't happen. As a consequence, you are going to break the slope. So obviously the water is going to log in different places. So anyway, to the cause and effects as far as climate change is concerned. And if we are through with this, let us go to the next slide. And this is something that we have been speaking about for a significant time. These are the four positions that the Earth attains around the Sun. And I did explain to you in my earlier lecture as to how the axis of the Earth, everything, see, nobody is moving actually. Every location, every celestial body is in fact in its own position. It is only this tilt, and that is why even a mere tilt of half a degree makes such a huge difference. And that is why I'm asking you all to go to Google and search what's the effect of eccentricity, what is the effect of say tilt in the axis, what is the effect of the precision. Okay, what all is do these cycles as an effect have on the Earth? The scale is huge. Okay, again you'll see I was referring to the scale. Now here again you'll see that the fortunately the Sun at least is shown a bit larger than the Earth, but we know that even in this scale, they do not match to each other. And of course, the distance also doesn't match to each other. So we spoke about these, and if you remember that the other day we spoke about the fact that we have just moved away from this particular position. Okay, this was, let us assume that this was 22nd of September, and by 23rd of December we would be somewhere here, and say March we would be here. This is called as the vernal equinox. We have just passed the autumnal equinox around, and we would be reaching the winter solstice, and of course then somewhere in June we would be having the summer solstice as such. Then this darkened and the lightened part, illuminated and the darkened part, this is called as the zone of illumination. That part of the earth which faces the sun is obviously going to have light, and that part of the earth which is away from the sun is going to have darkness. That's night. Okay, this is a very, this is not as simple as we understand it in the sheer meaning of day and night. You must have been seeing that say 26th of September I marked the fact that Dwarka, which is more or less central part of India, had 12 hours of day and 12 hours of night. And I did remind you that time also that the light aspect is different. The mathematical division of day and night by 12 and 12 hours, that's sunrise and sunset, is 12 hours each. And then few days down the line, it was in Pune. And if you see today, if you see Kanyakumari, I've posted it on our group as such, that Kanyakumari today is going to have exactly mathematical 12 hours of day and 12 hours of night. I'm referring to this mathematically because the zone of illumination, the tilt, and of course the atmospheric cover around the earth, all of them have a complex role to play as to how actually what actually are we going to call daylight, and what actually we are going to call as night, night as such. So these are a few things that would come across to us as we move ahead. And you can see the orbit of the earth, that's more or less elliptical. Again, this is, again I would remind you all, this is more of a geometric diagram. In fact, I would move the sun either way nearer to one of these positions, solstice positions as such. And in this whole process, I did explain to you using this and this the other day. I would say that this was the axis. Okay, this is how the axis behaves. Now you'll see that the axis is not changing. It may change as far as its Milankovitch cycles are concerned, but as the earth moves around the sun regularly, the axis is as it is. The earth is as it is. The sun is where it is, but it is this motion, the relative motion of this earth on its rotational axis, and of course the revolution that the earth goes around the sun. And in this process, the tilt in the axis, the role that the tilt in the axis has to play in all these issues as such, which gives us these fantastic combinations of a polar day somewhere, a polar night somewhere, 12 hours of day, 12 hours of night somewhere, 18 hours of day and 6 hours of night somewhere. So it's very interesting. And add to that these complexities, that the average distance of the earth and the sun is around 150 million kilometers. I worked up the circumference, this orbit. In that case, then if you are the circumference, as I told you the other day also, that this becomes the radius 150 million. So if I am to draw the circumference 2 pi r, it comes to around 942 million kilometers. Just imagine, at the place you are right now, even you are traveling at a tremendous pace. Okay, it's 942 million kilometers in 365 days. You divide it by 365, you'll get the number of kilometers in millions. Okay, this comes to around what? At least 3 million kilometers per day. If not 3 million, at least 2 million kilometers per day. Now you divide that 2 million kilometers by 24. So you'll get the speed of the earth per hour. You bring it down to seconds and minutes, you'll see that you are traveling for a few hundred kilometers per second, and you hardly are experiencing it around us. So you'll see that nature is just fantastic. You're traveling at such large speeds, you hardly are in, and just imagine that on a two-wheeler or in a four-wheeler, we just tend to extend the speed beyond 100, and then it starts to get wobbly, etc., etc. In fact, one of the reasons, now I come to that aspect wherein the eccentricity of the orbit, Why does the orbit shift between a perfect circle and an elliptical thing? That's basically because the speed at which the Earth is moving. The speed is so fast, so fast. And of course, the gravitational forces of pull and push between the Earth and the Sun, in fact, could vary, and as a consequence, this orbits also could vary. So this orbit has its own cycle between 1 lakh years to 4 lakh years, and so on and so forth. So these are a few interesting things. The more you think about it, the more fascinated you tend to get as far as these aspects are concerned. So this is something that I wanted to share with you all as far as some basic things. So what all have we done today? Here we have done the Milankovitch cycles. We have done the relative size of the sun and the planets. Of course, other planets we are not that much worried about. We are to concentrate on the size of the Earth in comparison to the sun. And of course, before that, we spoke about the very brief definition that geography is the study of the Earth in space and time. Okay, and the concept of scale and how man tends to view this particular aspects as such, and the fact that Geddes refers to all this as the subject geography as the mother of all sciences. I just close on this slide basically because this aspect of geography makes a student of geography a jack of all trades. You'll see that you tend to understand uh, everything, every bit of a thing in geography. So that's where that's what places geography uh, as a subject, I would say, which connects to the humanities part, which connects to the science parts, which connects to the commerce parts also. Humanities, I would say, sociology, I would say psychology, that's behavioral aspect. I would refer it to the other aspects. Okay, economics, for example, is something that I would refer to. Economic geography, in fact, is a specialization that you can take up in SP college and, of course, in the university as far as your MA/MSc geography is concerned. Then, as far as commerce is concerned, the foreign trade aspect, the value of a particular commodity at a particular place at a particular time. I told you space and time, okay, are important components of geography. So you'll see that making a particular commodity valuable is economics, in the sense that if it starts raining suddenly, what would you want? You would want a sweater, or would want an umbrella. So if there are two people, when it starts pouring down, and one of them is selling a sweater and one of them is selling a umbrella, which of these two sellers would the person, the people who are drenching in rain run to buy for? Okay, they would obviously buy. So it's making it available at the right time. So that is all. Say there is a lot of commerce behind geography and trade also. Okay, or rather, I would say there is a lot of geography behind commerce and trade also. And at the same time, you'll see that you are in two locations of India. Say, for example, you are in Rajasthan on one end, and you are in Cherrapunji, the other end as well. Now, you'll see that in Cherrapunji, you will not have that much amount of value for water. Of course, natural value for water is always going to be there. But in Cherrapunji, you will not have it basically because you have a lot of water there. Okay. On the other hand, in Rajasthan, they would die for water. Okay, in the literal sense also, and in the uh, flowery sense of use of language also. Okay, so while in the same commodity is in demand in what in Rajasthan, okay, in the monsoon, people in Cherrapunji would say that we are fed up of this rain and let this rain stop. God, let this rain stop. So the same commodity looked at a different. So making the commodity available at the right place and right time is the base of how geography leads into supporting commerce and trade. And then, of course, the science of geography also, the very reason that in our college itself we have it in, you heard it in the induction also, we have it in both the faculties, science as well as arts. Okay, there as I've been saying, there is physics in geography, there is chemistry in geography, there is biology in science geography, there is mathematics, there is statistics, there is electronics. Everything is obviously, and that is why I believe Sir Patrick Geddes refers to geography as the mother of all science. The answers, the final answer to questions posed in each of these questions could culminate into a subject called as geography. We'll stop here for today. When we meet day after tomorrow, we'll continue. We have some interesting aspects. We would be referring to latitudes and longitudes, and they are referencing in the whole scenario. Okay, that's all for the day today. And well, we'll stop here today, and we'll meet on Sunday the same time. Thank you very much. Not Sunday, sorry, Saturday, the same time.